Hey guys, what's up everyone? Welcome back to another video from the AP3X Institute of Mathematics. We are learning the language of the universe begins here, and it is of course one of the most important and universal language that we all need to learn. Alright, now in today's video we are going to be looking at one of the most important topics that spreads itself right across the curriculum, no matter what level of math you're doing, whether it be secondary education, tertiary education, or even if you're doing your advanced math courses. Solving equations are going to be vitally important. Not only just solving equations that are already created, but solving worded equations. Now, this is just part one of a few videos that are coming out as it relates to equations. We're going to be looking at other videos such as quadratic equations, simultaneous equations, worded problems. So if this is the first time here on the channel, of course, do not forget to smash that subscribe button below. Leave a like if you're getting some sort of value from the video. And of course, do not forget to leave a comment down below expressing how you feel about the lessons being taught here. Now let's jump right into the video, and we're going to be talking about multi-step equations and inequations. All right, now I did went ahead for you here to actually lay out some rules as it relates to solving equations, and I would more likely say that they're not really rules, so to speak, but they're more like things that you need to be aware of. All right, but I just call them rules for conversational purposes. All right, so here we go. We're going to be looking at multi-step equations and inequations, and we're just going to take about a few minutes here and kind of run through the rules. And as we are going through the examples, which I have a ton load for you here, as we are going through the examples, we are going to be highlighting which rules are popping up. All right, now as it relates to equations, guys, one of the main aim that you have to keep focus on once you're solving an equation, whether it may look a little bit complicated in appearance or it may just be a very simple equation, is that the aim is to isolate the unknown variable. Right, the aim is to get that variable to be by itself using a mathematical process. All right, we're going to be going through all those processes for you. Now, there are two methods of actually aiming to isolate your variable, and one is what we call transposition, and the other is, well, a variance to transposition is what is referred to as balancing both sides of the equation using the same operation. All right, now number 3 here, we're looking at using the transposition method. Right, once you're going to be transposing a term or you're going to be transposing a numerical value, it is always important for you to remember that you transpose in the direction that contains the larger coefficient. As it relates to why we do that or why I do that, it all boils down to making the route to getting to your answer a lot simpler. All right, but I will highlight some methods for you there. And number 4, in the event that you end up with a negative coefficient or a negative sign in front of your variable, especially when it comes to an inequation, you must remember that you need to reverse the sign. Now, reversing the sign means that if you happen to have to multiply both equations by a negative value, or you have to divide both sides of an inequation by a negative value, you must remember to reverse the sign. Now, you can avoid a situation like number 4 by always applying number 3, transposing in the direction that contains the larger coefficient. Once you apply number 3 effectively, you'll never have to deal with number 4. All right, And just another little thing here, that if there isn't a visible numerical coefficient, if you don't see an actual value in front of your variable, then there is an understood value of 1 or -1. All right, so it's very, very important that you remember that. And I did forget to mention one thing as it relates to number 2, that transposition. Once you're bringing or you're transposing something across the inequality or the equal sign, you must remember to change your sign. All right, now leave a like if you haven't already. Leave a like, go right ahead and smash that like button so we can get this content out to more students who are having problems in this area of mathematics. All right, so we're just going to go right ahead now, and we are going to jump right into the examples. Now I have some equations set up here for you, and we're going to just go through a few of them, probably not all, because I want to touch base on some of the easy ones. I want to touch base on some of the more challenging ones, and we also want to look at some more examples as it relates to the linear inequations. All right, so let's get into some examples here. Now it says here that you're to solve and check the following equations, and you must show all your steps. So here we go. First example here states that 4x plus 20 is equal to 0. All right, very simple equation, but let's not take it for granted. It is definitely something worth putting your time into. All right, so here the first thing that we're going to need to do here is to focus on isolating the variable, which in this case is going to be x in this case. So we now need to transpose the 20 and balance both sides of the equation by dividing by 4. So with that said, transposition here is best. So we could just bring that 20 across to the right hand side of the equation, and we would end up with 4x is equal to -20. All right, and then we are going to then divide both sides of the equation by 4. Remember that once you're multiplying or dividing an equation by a specific coefficient, whatever you do to one side of the equation, you must balance the other side by using the same operation. So now we'll end up here with 4x divided by 4, and that is going to be equal to -20 divided by 4, and we'll end up with a very simple solution here. Crossing out the two 4's here, we'll end up with x being equal to -5. All right, now that's what I would refer to as a shortcut method in getting to your answer. I'm going to use another method now in example number 7 here, this example, right, where we don't necessarily have to do this arrow thing here. There's a lot of other YouTube videos out there that actually use a different technique, so I'm going to show you that in this example. All right, so here we have 5x take away 3 is equal to 2x take away 27. All right, now the method I'm going to show you now is a little tedious, especially when the problem becomes a bit technical. So I personally, from a personal point of view, I don't recommend using this method, but if you know what you're doing and you're comfortable with the method, then by all means run right ahead with it. But what we can do here is that the first aim here is to try to get the variables on one side of the equation. Now you have a choice here. You can actually transpose the +2 to the left side, or you can transpose the 5x to the right side. Now transpositional direction doesn't matter once you know what you're doing, but like I mentioned earlier in one of my rules, and if you can just go back a little bit here, You'll remember when I told you that using transposition method, it is always best to transpose in the direction of the larger coefficient to ensure that your unknown variable remains positive. So number 3 plays an important role here. So I would recommend, just to make it easy for you, that you transpose the 2x. You transpose the 2x in this side here. Now, we're not going to be using the transposition technique. We're going to be using the balancing both sides technique. Now, since this is a positive 2 and our aim is to try to get it to the left side, or the aim is to try to remove the 2x from the right side of the equation, then what we could do is that we could subtract 2x from both sides. All right, so what we'll end up with here is, say, 5x subtract 2x subtract 3. So I'm subtracting 2x from the left side, and I'm also going to balance the equation by subtracting 2x from the right side. And you have a lot of YouTube videos out there that actually use this technique. Now, once we have subtracted 2x from both sides, you're going to find here that this 2x here will cancel this 2x over here, and then what you're going to end up with now is 5x take away 2x gives us 3x, and then we'd had the minus 3 here, and that would now be equivalent to negative 27. Alright, so if you're watching this YouTube video from another country other than the country that I'm in, then you can use that technique. Now, personally, I don't really like that technique. It's a little bit longer and it's a little bit more tedious. But if you are comfortable with it, then by all means, as I said, go right ahead. Now, we can go ahead now and do the same thing for the minus 3 here. Since this is a negative 3, we're going to balance both sides of the equation by adding 3 to both sides. So we'll end up with 3x here minus 3. We're going to add 3 here because the aim is to eliminate that minus 3. And we're going to balance the other side of the equation by adding 3. Alright. So now we are going to end up now. I'm just going to go right over here to this little part here. So we're going to end up here minus 3 cancelling plus 3. Opposite signs, that's the additive inverse identity. So we'll end up with 3x here being equal to negative 27 plus 3 gives us negative 24. Okay, now if we can balance both sides of the equation here by dividing both sides by 3, we'll end up with 3x divided by 3 is equal to negative 24 divided by 3. Cancelling out here, we'll get a final result here that x is equal to minus 8. Alright, and that is our solution. Now, as you can see, that we literally took a problem that could have been made a little bit easier in terms of the amount of steps, but my channel, we expose all methods. We give students options that you prefer. Now, if you prefer just using this arrow transposition technique here, it is mathematically legal to do that as long as you remember to change your sign. Now, in this method here, we don't have to really remember to change any signs because the signs automatically change itself once you are doing the opposite operation to remove the unwanted term or unknown term or numerical value. All right, so that is it for that method. I'm actually going to just erase here, so make sure that you guys are following, taking a screenshot, or you're writing with me. I'm going to just kind of erase here to give myself some space for another example. All right, so there we go. All right, so those two examples, you can see that number 8 here is of a similar nature to number 7. So you could actually go ahead and you can try number 8 here and let me know in the comments. All right, what did you get? And I'll definitely respond to you. Let's just jump right ahead here to number 9, which looks a little different from all the other examples. So here we go, number 9 here. We have 12 take away 3x is equal to 22 plus 2x. Now, for the purpose of this video, I'm actually not going to be using the balancing both sides of the equation technique. I'm just going to be using the whole very similar technique of transposing using the arrow. So here, all I'm going to do here now is just focus on trying to get my variables to be on one side. Now, remember I mentioned to you that awareness number 3, or rule number 3, so to speak, is that I always aim to transpose my variable to the side that contains the larger coefficient. Now, in this example here, a lot of you guys may think that this here would have been the larger number, because if you're not paying close attention, then you will almost think that this is 3. All right, and so you'd feel the need to actually transpose the 2x to the left side. Now, if you do that, you're going to find that you're going to have a negative coefficient. And like I said, nothing is wrong with having a negative coefficient. But if you want your process to getting to your answer a lot easier and less complicated, you always want to remember to transpose to the side that contains the larger coefficient. Now, why is that so important for you to follow? Is that when it comes to solving a linear inequation, sometimes you end up with a negative number where, as I mentioned to you before, let's go down to number 5 here, you're going to have to remember to reverse the sign. And many students who are not very strong when it comes to solving equations tend to always forget that little simple step. When it comes to putting your answer on the number line, you end up doing the opposite of what is expected. So like I said, I might have to make a part 2 to this video, just kind of going through more examples, but I'm going to try to make this at least a 45-minute video that actually is that's very condensed, so we can sit down and do like a couple of examples and go through all the intricate details. So here we go, let's jump into this example. I recognize that 2x is larger than minus 3x. This is a negative here. So instead of bringing my 2x, which is what I'm tempted to do, I'm just going to bring my negative 3x here to the right side of the equation. Now, bringing that negative 3x over to the right side, that will kind of force me now to bring my 22 over to the left side, because I do not want my variable to be on the same side as my numerical values. So now what I have here is that I will leave my 12 alone, and I will transpose the 22 across here. That's negative 22. Remember, it's positive, so I bring it across, it's negative. And that's going to be equal now to 2x, which I did not actually touch. And I'll transpose now the minus 3x over here, and I'll end up with a positive 3x. All right. Now, if you were balancing both sides of the equation, then it would be a little bit lengthy in terms of amount of things that I have to write. So using this technique is far more simpler. That is in my opinion. Okay, now 12 take away 22 is equal to negative 10. Pardon me, I should not have an equal sign there. It should be negative 10. And that's going to be equal now to 2x plus 3x gives us 5x. Now try to always remember to actually use your calculator and make sure that you verify your answer if you're not very good at adding directed numbers. So negative 10, we're going to balance both sides of the equation here by dividing both sides by 5. So we end up with 5x divided by 5. And that's going to be equal to negative 10 divided by 5. And by cancelling the minus 5 over here, we end up with an answer that says x is equal to minus 2. Okay, now you can see that we are reading the answer towards the left when we are most accustomed to reading the answer towards the right, but either ways the answer is going to be correct. All right, so hopefully you guys got some value from that content there. As you can see that most of the examples are more or less the same, so we're just gonna skip right along down to here we end up with number 16 here. All right, so number 16 looks a little different from all the others. Make sure that you guys are pausing the video and you can actually work them out and leave your answer down in the comment section and I will verify if your answer is correct. All right, so here we go. We're going to jump to number 16 and 17 and see if this can give you some value. So here we go. Now when you look at number 16, the first thing that I recognized when it comes to this particular problem here is that the fact that my variable that I'm searching for has a negative sign in front of it. I don't like that. I kind of prefer if my variable has a positive sign. Now, I have two ways in which I can actually work through this problem. I'm going to show you both ways. All right. Now, if I want, I could actually go ahead and transpose the 24 to the right side. Since as there is not much to do, all I have to do is just remove that 24 and I'll get the x to be by itself. Well, I'll get the minus x to be by itself. So in this case here, if I take 26 and I transpose the 24 to the left side, I'll get negative 24. And I find that a lot of my students, what they'll do is that after doing that, they forget to put down the minus sign. So they'll leave the x like that. Now you have to be very careful because another rule that you also need to be aware of, well, not so much of a rule, but you just need to be very aware that once you're transposing a variable, you have to pay attention to the sign that is in front of the variable or the numerical value. Please note that any sign that is in front of a variable belongs to the variable. So here I am transposing the 24. The negative here belongs to the x. It doesn't belong to the 24. So when you transpose the 24, you're actually transposing a positive 24, which is why it now becomes negative 24. So what is left over here is minus x. That's what's left over here. Now we have not yet isolated the x. Now if we go back to the rules that we have over here and we go down to number 5, I did mention to you that if there isn't a physical or visible numerical value or numerical coefficient, then you must remember that there is an understood value of minus 1 or 1. Now in this case here, you'll find that the actual value that is in front of x here is actually a minus 1. So you can actually go ahead now and divide both sides of the equation by minus 1. And we already mentioned that here 26 take away 24 is 2. So we're going to divide over here by minus 1. All right. Now we don't need to put a 1 here to show the marker that that's what is there. We already understand that the minus 1 here, understood value here, is going to cancel. All right, pardon me. All right, there we go. Had a glitch in my system here. So we're going to be canceling here the minus 1 and the minus 1, and we'll end up with x being equal here to minus 2. 2 divided by negative 1 is negative 2. All right, so that is where we are at. Now there is actually a far easier method in getting to your answer in actually one line. Now if this is what you prefer, then by all means go right ahead. For me personally, looking at the problem at first glance, the first thing that I thought that I needed to do was just try to get the x to become positive. So I didn't think that transposing the 24 would have been the easier method. I thought that if I brought the negative x over here and I brought the 26 over here, I would have gotten to my answer far quicker. So if I brought negative x to the left side, I would have ended up with positive x. And notice I didn't touch the 24, I left it alone, and I brought the 26 over to the right side, which gave me negative 26. So now I end up with an easy answer that says x is equal to minus 2. Now I know a lot of you guys are saying, oh, well, this is far easier, sir. I prefer this method. Yes, I know. But then again, can you remember to transpose the variable? I guess based on who is teaching you or based on where you've learned your lesson before, you're so accustomed to transposing the numerical value rather than the variable. Here's a news flash. Here's a fun fact. You can transpose whatever you decide or whatever you choose best. But always remember to keep your variable positive. All right? All right, here we go. So now we're going to be looking at here. We're going to be looking at example number 17 here, and now it involves a bracket. All right. Now I'm using this very simple example here because then I'm going to perhaps go on to a little bit more complicated one that involves all of what we discuss plus all of what we discussed before plus involving brackets. So let's just make it easier. Now, when you end up in an example here that contains brackets, then what plays an important role in solving this equation is the distributive law of mathematics. That's an arithmetic law. So what that means now for those who are actually learning this for the first time is that whatever that is outside of the parenthesis must be used to multiply what is on the inside of the parenthesis. Now, one important fact here that you must remember going forward is that not only should you use whatever is on the outside to multiply what is on the inside, but it has to be what immediately precedes the parenthesis. Parenthesis in this case means the brackets that you're seeing here. Okay, so it doesn't mean that if I have 6 terms or 3 terms or 2 terms outside the bracket, I'm going to use both terms to distribute. I'm only going to be using the term or the numerical value that immediately precedes the bracket. So here I'm just going to be using the 2 here to multiply the 6x and use the 2 here to multiply the minus 7. So 2 multiplied by 6x gives us 12x. And 2 multiplied by minus 7 gives us minus 14. And so that's going to be equal to 10. All right. Okay. So now what we end up here with is 12x take away 14 is equal to 10. Now we are going to transpose the 14. We've seen this situation come up earlier, so we all know that we're going to transpose the negative 14 here, and that's going to give us 12x is therefore equal to 10, and the negative 14 has been transposed, it becomes positive 14, and we find that 12x is then equal to 24. Now if we divide both sides of the equation by 12, so that's going to be 12x divided by 12, and the 24 divided by 12, you're going to find that the 12 cancels on the left, and we end up with an answer. I'm running out of space here, guys, but I guess you can see here that x here will work out to be equal to 2. All right, run out a little bit of space there, guys, but there you have it. X is equal to 2. 24 divided by 12 is 2. All right, so hopefully you guys got a hang of that particular problem there. Let's turn up the heat a little bit by just looking at an example that involves brackets along with the others here. All right, so I'm going to actually do question 20 instead. All right, because I have it in the middle, so it kind of makes it a little bit it looks a little bit more complicated, and it kind of highlights the fact that there is now two terms that is outside the parenthesis. Is it the case that I use the 4 to multiply inside the bracket, or do I use the 14 to multiply inside the bracket, or do I add the 4 to the 14 and then distribute it in the bracket, or do I just use both simultaneously? Well, if your guess was using the 4 to distribute, then you are correct. Any other method or any other technique that you were thinking about, that would be incorrect. Number one, we cannot add before we multiply according to the PEMDAS rule. So that's illegal. We cannot add 4 to 14 and then distribute. So this would mean that we'd have to distribute the 4 inside the bracket. So we'd write down the 14 here, and we would therefore distribute the 4 inside the bracket here. And then we would actually distribute the 4 with the -5. So now we would end up here with 14 plus 4 times x is 4x, and 4 times -5 is -20. And that's going to be equivalent to 6 take away 2x. Alright? Now, we need to stay focused now, guys, because what I find that a lot of students do is that once they start and they actually get through the first obstacle, they begin to confuse themselves. You have to remember the basic rules of solving equation, and that is trying to get the variable to be by itself. That is why I place it at number 1. You have to remember every time that you complete an operation or you complete a step, you constantly have to remind yourself that the aim is to get the variable to be by itself on either side. So I have a 4x here, and I noticed here that I have a negative 2x on the right side. Obviously, positive 4 is larger than negative 2, so I would transpose the 2x to the left side. So here I would let me just zoom up a little bit here for you. I would transpose the -2x all the way over here. Now, the mere fact that I actually brought the negative 2x over here, that would force me now to bring the 14 back over here, because I need all the numerical values to be on one side. Notice here that I also have a negative 20 that is on the left. I need that to be on the other side. So it looks a little complicated here with all these arrows, but as you can see here, the aim of these arrows is to just give you the direction in which I'm carrying the numbers or the terms. So here, notice that the only thing that I didn't actually place a indicator on is the 4x. And you'll find that the -2x here comes across. It becomes positive 2x. I now have the variables on one side, and you're gonna find here that I didn't actually make mention of the 6, so I leave that alone. And I brought the negative 20 over, it becomes positive 20. And if you notice here that I also brought the 14 over, it becomes -14. Beautiful. Alright, now we're actually almost done. 4x plus 2x is equal to 6x. And you're going to find that 6 plus 20 is 26. And 26 take away 14 is actually going to give us, let's see here, that's 26, that's 16, that's 12. Okay? And as per usual, we balance both sides of the equation by dividing by 6. And you'll find that your result here works out to actually be equal to 2. Alright, so x here works out to be 2. Alright, so as you can see there, guys, just a few examples we were actually able to go through. Make sure that you guys are actually taking a screenshot of this, and you can actually work out your problems, tag it in the comment section, number 7, number 11, number 15, leave your answer below or show your solution, and I will confirm by responding to you if your answer is indeed correct. All right. Now there are actually some more examples. You can find my contact information down in the description box below. You can reach out to me to send me your solutions. You can reach out to me via email, and all the social media links are going to be in the description box below if you need to get in touch with me wherever you are watching this content and you need verification on your answer. I'll be happy to respond to you. All right, so the examples around here are more or less the same. I may have to make a part 2. I'm actually going to go through one of these problems. Now, as you can see here, let's just have a look at number 15 here. Just looking at it, sometimes a little bit scary. All right, so I'm going to go through number 15 and then we're going to jump to the inequations. Okay, so we're going to jump to the inequations. So here, looking at number 15, just to clear up how it may look, I may look at number 15 and 17. Looks a little tricky, so that you guys can be comfortable doing the other problems. So here we go, number 15. So when you look at number 15 now, guys, it, as I said, probably comes off a little scary. Probably you're not sure what you got to do, but remember, all the rules still apply regardless of how the equation wants to look. Now, the first thing that I do see here is that I need to simplify this problem to make it appear a little bit easier. And I do see some things that I can simplify here. The first thing that I see actually here is to actually simplify the 9 with the minus 11. I could make that become one number, and I realize that there's a couple of distributions that I need to do here. Okay, I realize that I could distribute the minus 2 and I could distribute the minus 3. So if I do that, I should have a simpler problem in the next step. So let's do that first. Let's take down our 10p. And notice here that 9 and minus 11 are numerical values or like terms. So we could actually work that out and we'll end up with minus 2. All right. And that's going to be taken away from p. Or p is going to be taken away from that. And that's going to be equal to, now we're going to distribute the brackets here. So we end up with negative 2 multiplied by 2p gives us negative 4p, and negative 2 multiplied by positive 4 gives us negative 8, and negative multiplied by a positive gives us a negative. We'll proceed now to working out distributing the minus 3. So minus 3 multiplied by 2p gives us minus 6p, and minus 3 multiplied by minus 2 gives positive 6. All right, now that we got rid of those complications, now we once again have to focus on trying to get the variables to be on one side. Notice that I have the 10p over here already, and it is the largest of all the p's. This is minus 4p, this is minus 6p. So that would mean that I will need to bring this negative 4p to the left and bring this 6p to the left to join it with this minus p here. So I have 10p, take away p, that's this p here, bring this minus 4p, I'll end up with a positive 4p, and I can actually bring this negative 6p and I'll end up with a positive 6p. And you're gonna find here that this is actually equal now to, notice the numbers that I didn't touch was minus 8, and I didn't touch the positive 6, but now I need to bring this negative 2 across to the right side. That's positive 2. All right, very good. Now let's simplify. But before we simplify, it's always good to just double check a little bit, make sure that all the terms that we have written down into the third line here is actually matching the same amount of digits that is in the second line. So we have 1, 2, 3, 4, 5, 6, 7. 7 terms here. 1, 2, 3, 4, 5, 6, 7. So we are okay. We haven't missed out anything. All right. So now it's time to just do some basic addition here. 10 take away, remember that there's a 1 that is in front of the p. So 10 take away 1 is 9. 9 plus 4 is 13. 13 plus 6 is 19. So that's 19p. Alright, and it doesn't hurt to check. 10 take away 1 is 9. 9 plus 4 is 13. 13 plus 6 is 19. And that's going to be now equal to negative 8 plus 6 is negative 2. And negative 2 plus 2 is 0. Alright, and please use your calculator to verify. It's always good if you can do it in your head without a calculator, but use your calculator to verify your result. So P here is equal to 0 divided by 19, or pardon me, I'm going to stick with the method. I'm going to divide both sides by 19. And you're going to find that P is equal to 0 over 19, which works out to be 0. P is 0, all right, for that particular problem. All right, so it just looks a little complicated, but once you apply the steps, then you should be okay. All right, now number 17 is more or less the same sort of problem, but I'm actually going to go through number 17 to make sure that you guys are comfortable. All right, because it can be a little tricky. All right, now here we go. Number 17. First thing I see is something to distribute. So if I can go ahead now and distribute my 10 here. And here's the little problem that we have here. Here, a lot of students may not realize that there is actually a -1 that is in front of the bracket here. All right. Some teachers will say distribute the sign, but in fact, what we're actually doing is that we are distributing the -1. All right. So what we're doing here is that we're using -1 to multiply inside the bracket here. That's what we're actually doing. But as I said, distributing the sign is more or less mentally the same thing that we're doing. But it's best to just let you know that there is actually a -1 that is in front of the bracket here. So we have 10 multiplied by x gives us 10x. And 10 multiplied by 3 gives us 30. -1 multiplied by -9x. We know that 1 multiplied by 9 is 9. And negative multiplied by a negative is a positive, so that's positive 9x. -1 multiplied by -4 gives us positive 4. And that's going to be equal to x take away 5 plus 3. All right. Now we organize, get everything to be organized according to the terms that are alike. So you notice here that we have the 10x on the left, and we also have the 9x already here on the left. And all I'm doing here is just moving this x somewhere over here. So I end up with a -x. I have all my x's on one side. Now I'm going to put all my numbers on the other side. So here I would have already had the -5 over here. And I would have already had the 3. I would then go ahead and move the positive 4 over here. So that's -4. And I would also move the positive 30 all the way over here to get -30. So I would have actually had 7 terms here that matches 7 terms in the second line. 10 plus 9 is 19. 19 take away 1x is 18x. And that's going to be equivalent to -5 plus 3, that's -2. -2 at this point, take away 4 is -6. And now -6 minus 30 is -36. Punch that in your calculator, verify your answer, guys. So that's 18x, pardon me, divided by 18 is then equal to -36 divided by 18. You're going to find easily that x works out here to be minus 2. All right, so hopefully guys, you are able to do all the other problems on your own. Now we're gonna jump right ahead now to solving a bit of linear inequalities. All right, but if you haven't smashed that like button yet, guys, go ahead and do so. It helps with the algorithm to help YouTube to get this to other students across the world. So help me get this video out there and share the content. Leave a like, leave a comment down below. We're going to just go through a few examples as it relates to the linear inequality. But the difference between an inequality or inequation is the mere fact that our solutions are going to be a range of values. With an equation, you're going to find that the answer is always one value. Let me just give you a chance there to take a screenshot. All right, there we go. You should be able to take a screenshot by now. All right, there we go. And so we're just going to be working just a few of these and just have you work the rest. And just let me know in the comments if this video or you need another video that will explain in more details any other intricate things that you may not be clear on. So here, let's solve. Let's look at number 2 here. So now we end up with 4x plus 1 minus 1 is greater than or equal to minus 8. All the rules apply. Nothing changes. It doesn't matter the sign that we're using here. It is treated as an equal sign. So we'll end up with 4x here. And we could work out 1 minus 1. We'll find that the answer there is 0. And that's going to be greater than or equal to minus 8. Now, if we go right ahead here and we transpose the plus 0, you find that we end up with 4x is greater than or equal to minus 8 plus 0. So that's 4x is greater than or equal to minus 8. Now if we go ahead now and balance both sides of the equation by dividing by 4, you're going to find that x now is greater than or equal to minus 2. Now, as I mentioned before, the difference between an inequality, which in this case is x is greater than minus 2, greater than or equal to minus 2, you're going to find that there is more than one possible values that will make the inequality true. So what we do is that we go on our number line, and because it's greater than or equal to minus 2, we would circle the minus 2. Pardon me. We would circle the minus 2. And we would actually shade it. Okay, that's not minus 2. It's actually minus 1. Let's circle the minus 2. And we would shade it. And we would send an arrow in this direction. That shows that the answer to this inequality has to be minus 2 or greater. All right, that is how you solve that equation there, that inequality there. All right, so they're all the same. They're all the same. All right, now here's a little tricky one that we end up with at times, and I want you guys to pay close attention to this one here, where we end up with, okay, well, this is not actually the one I was referring to. That one is also a very nice one to work out, guys. But let's look at number 6 specifically. Now, with number 6, there's not much work to do, but you're going to find that the rule that I talked about, where we have to reverse the sign, will come into play here. Because as you can see, if you're going to be attempting this question, you'll realize that there is no need for you to actually transpose. There's actually no need to transpose because the variable, which in this case is p, is on the same side. So you're going to find here that it only makes sense to subtract the 4 from the 2, which you're going to find that the answer is minus 2p. Alright, so 2p, take away 4p, is equal to negative 2p. In this case, it's unavoidable. It's unavoidable to a certain extent, where you cannot avoid your coefficient being negative, because it's going to be a little bit more complicated to transpose it so that it can just become positive. So it makes sense that you just go ahead and work it out. So notice now that I'm going to have to be dividing both sides of the inequality by a negative coefficient. And so because I'm dividing by a negative coefficient, I'm going to have to reverse my sign. Now, failure to do that is that when you go on the number line, you're going to be sending or indicating that your answer is going to be in the opposite direction. So rather than having the correct answer, which is going to be p is greater than or equal to -1, you end up with p is less than or equal to -1, which sends your answer in this direction instead of being in the correct direction, which is this way. All right, so now we're going to have the answer correctly being equal to -1, greater than or equal to. So we'd circle the -1 here, and send the arrow this direction. Now our answer is p is greater than or equal to -1. Alright, so now I have some examples down here for you with some brackets distribution law here. We also have this example with this -1 that we have to distribute inside the bracket. Give those a try. Let me know in the comment section. I do have some other examples around here for you. I think I need to wrap up this video now by just doing one of these complicated examples for you, or these examples that apparently looks complicated, and you can let me know what the others are like. All right, here we go. Final example of this video, guys. Let's get into it here. We're going to distribute the -6 and distribute the 6 again here. There's not much to do, just the distribution law here. -6 multiplied by 1 is -6. And -6 multiplied by +2 is -12. X is greater than or equal to 6 times 2 again is 12x. And 6 multiplied by -1 is -6 plus the 2x. Now, getting the x's on one side, you can find that 12x is larger than -12x, and also 2x is larger than -12x. So it is safe to transpose, or safest to transpose the -12 over to the right side. But if you find yourself tempted to bring the -12 here or the +12 over here, you have to remember that if your variable ends up with a negative sign in front of it, you must remember to reverse the sign. So I'm just going to go ahead and then entertain you for a moment by bringing this over here. So I'm going to end up with -12x. And I'm going to bring this +12x. It's going to also become -12x. I'm going to also bring this 2x over, which is also going to become -2x. That's greater than or equal to -6. And I'm going to bring this -6 over here. I'm going to become +6. So -12x minus 12x is -24. -24 minus 2 is going to become -26x. That's greater than or equal to -6 plus 6 is 0. All right. Hopefully nobody's adding the numbers here and rewriting the negative. We should be by that stage by now. So -26x divided by -26 is equal to 0 divided by -26. Cancel, cancel. And it's not equal, pardon me. Notice that I divided by a negative, so I have to reverse this sign to become less than or equal to. So now I end up with x being less than or equal to x is less than or equal to 0. Alright, so that brings us to the end of that particular question there. Let's put it on our number line. So we're going to find here that 0 is our answer. Shade it here and send the arrow in this direction. All right. Now I didn't do an example that didn't involve equal to, like this example here. When you get to an example like that, remember that you do not shade the circle. Do not shade the circle once it doesn't have that line underneath. When I'm shading the circle, I'm indicating that the answer has to include that value. When I don't shade the circle, then it means that the answer doesn't include that result. All right, so definitely let me know in the comment section below if you're getting some value or if you got some value from the video. I think this is more like a complete tutorial as it relates to solving equations. I didn't have to do a lot of examples, as you can see, just going through a few examples here with you, and I thought that it would have been enough for you to actually get some guidance. Now, if you want me to actually do a part 2 by working through the problems so that you can match my solution with yours, let me know down in the comments. Do not forget to smash the like button below. Do not forget to share my content, and of course, do well, continue practicing, have goals, have objectives to becoming better at math, and I'll see you in another tutorial video. Take care. My name is Akeem, and I'm your math guru. Bye bye.